Dobre utro. Unfortunately, that's where the Ukrainian-Russian stops. So, my name is Simon Ritter, and I work for Oracle as a technology evangelist. It's a great job title. And what it means is that I go around and I talk to people like you. People who are interested in technology. So I don't work in marketing, I don't work in sales, I do technical stuff. Having said that, the first presentation is not going to be really deep technical. This is going to be more of a sort of higher level technical talk in terms of what Oracle are doing for Java. So what's our plans, what's our roadmap, what's the direction that we're going in terms of Java. And so I'm really hoping actually today that my voice is going to last, because I seem to have picked up some sort of throat infection. I'm really hoping that my voice is going to hold out for the whole day. So that's me, technology evangelist at Oracle. I worked for Sun for 14 years before we were acquired by Oracle. And one of the first things you notice when you become an Oracle employee rather than a Sun employee is that lawyers get involved in almost everything. And so I have to put this slide up in all of my presentations because I'm told to by our lawyers. Basically it says, don't believe anything I'm about to tell you for the next 60 minutes. Well, actually, no, it doesn't say that. It really says, don't base any purchasing decisions on what I'm going to tell you. And since we give most of Java away for free, I don't really see how that's too relevant. But the lawyers say I have to put it there, so I think you've had long enough to read it. So what is our goal in terms of Java? Oracle acquired Sun just about 2 years ago now, a little bit over 2 years ago. And one of the things that Oracle wanted to do was to acquire the technologies of Sun. There was Java, there was Solaris, there was the hardware business. And they wanted to use that to really integrate into all of their product lines and be able to give customers the best possible options in terms of the products that they could sell them. Now Java is a very interesting beast in many ways because it's not really one thing. There's lots of different aspects to Java. Yes, there's Java the language, but there's also Java the virtual machine, Java the class libraries, Java the community. So Oracle had to adjust a lot to what Java really was. They couldn't treat it just like another product that they had in the past. And so this is really kind of outlining what the future directions that Oracle have in mind for Java. So we want to make the platform as complete as possible. We want to make sure that Java addresses all of the needs of developers, because it's clear that the way that applications are being developed, the types of applications that are being developed is changing over time. Yes, we still do sort of data entry type applications, but there are much more diverse types of applications being developed. The whole mobile side of things, the whole embedded side of things is really changing a lot of the applications that are being developed. So we need to make sure that the platform is complete in terms of what it offers to you to developers in terms of creating those applications. We need to make sure that we keep it modern. We need to make sure that we keep innovating. And a lot of that actually happens sort of underneath the covers. It happens in terms of the JVM. How we approach things like garbage collection, how we approach things like adaptive compilation, how we approach things like concurrency. All of these things are areas where we can continue to modernize, we can continue to innovate in how we can get the best possible performance from Java and therefore deliver the best possible performance to your applications. So that's very important as well. Developer productivity is essential. Now, in terms of the language, Java is 17 years old now, and we've gradually changed a few things over time, but mostly it's still pretty much the way it was when we launched it. But what we're trying to do is look at what are the small ways that we can change Java to improve productivity for developers, make it easier to write code. Java as a language is Turing complete, which means you can write any application that you can think of that can be written as a computer program. So the changes we're making are more about how do we make life simpler. If you look at things like Java SE7, the try with resources that we introduced there, that's really about making life a whole lot easier if you want to have a number of like input streams and output streams, and guaranteeing that all of them get closed properly. So now you don't have to nest all those nasty try finally blocks. You can just use try with resources and let the compiler do the hard work for you. It makes your code easier to write. It also makes it more robust. You don't have to catch so many errors. So that's the kind of thing we're looking at, how to improve developer productivity. We want to make the evolution of Java open and transparent. We have the Java community process, which is all about getting people other than Oracle involved in the development of Java. So we want other companies, we want IBM, we want Apple, we want other companies that are interested in helping to develop Java. But we also want individuals. So we want individuals to help review specifications, help add things to specifications, contribute to specifications. That's all very important. And we want to do that in a transparent way. So one of the things we're doing at the moment is modernizing the whole Java community process in terms of making mailing lists available to the public. So you can see what's going on in terms of an expert group as the specification is being developed. That way you don't have to wait until the public review comes out and then figure out, oh, this is what is in the specification. You can see the discussion that's going on, you can see the issues that are developing as they actually happen. We want active community involvement. I think that the fact that there's several hundred people here today on a Saturday is wonderful, because that shows community involvement. The fact that you decided to give up part of your weekend to come and listen to me talk is, well, it certainly makes me kind of think, wow, that's impressive. So we want to make sure that the community gets involved. Java user groups, we have a Java Champions program. We want to make sure that as much as possible, it's not just Oracle saying, this is what Java is, this is what you get to do. We want you to be involved and help grow the whole thing. And lastly, but by no means least, is the whole idea of quality and security. Now, this is something that's come up recently, because there have been some issues around this, but we want to make sure that moving forward, we have the most high quality product in terms of the Java platform. We want to make sure that there are as few issues around security as possible. So this again is where the community can help be involved. Things like the OpenJDK project, looking at code, the more eyes that look at the code, the easier it is to spot potential flaws. So from a perspective of our strategy and our vision, drilling down into the individual sort of areas of Java, like I say, Java is a many-faceted thing. And so it's not just about like the fact that you have Java, the language, and Java, the virtual machine. There's also these different sort of definitions of Java in terms of the platform. So start with Java SE, standard edition, the language and so on. What we're doing there is looking at JDK 7. We released that last year. That's proved to be very successful so far. It was really a way to get Java kick-started again, because it had been a long time since the previous release. Java SE 6 came out in 2006, so it was 5 years between releases, and that's a long time. So we wanted to include as much as we could at that point. We got out a good solid release, and people are really sort of picking that up and starting to use it. Show of hands, who here is using Java SE 7 at the moment? Okay, we'll have to work on that. But I do understand that there are a lot of issues in terms of moving to newer versions. I talk to a lot of banks and financial institutions and different companies, and they all say, well, yes, it's very nice, we would love to move to the latest version, but we have to go through all the QA, we have to go through all the testing, we have to make sure that everything works exactly as it should. It's a big job. So yes, JDK 8 and 9, we're working very hard at the moment on Java SE 8. This will be coming out sometime towards the end of next year. This is going to include some, well, at least one very big feature from the point of view of Java. We're introducing Lambda expressions, the idea of closures in Java. And I'm going to do a presentation on that this afternoon, so I'll talk in a lot more detail about that later on in terms of what that means. But it's really about introducing some functional elements of programming into Java, replacing the whole idea of using anonymous inner classes with single abstract method types and making life a whole lot easier. So you can effectively pass a reference to a method as a parameter to another method. We have plans going beyond JDK 8. We've got ideas for what we want to do all the way out to Java 12 at the moment, and basing that on a release cycle which we're aiming for in terms of 2 years between releases. We're looking at somewhere in a range of 2021 for the release of Java 12. And like I say, we have some ideas about things that we'd like to put in there. Now, I'll mention a few of those things as we go through. JavaFX has had an interesting history. It's the idea of really providing a replacement, if you like, for Swing and AWT. A much more modern way of developing applications that have a user interface. And so again, I'm going to talk about that in much more detail in the session later on, so I won't go into too much detail here. But it is all about rich interface applications, support for things like HTML5, style sheets, XML markup language to define the layout and so on. So we'll go into that in a lot more detail later on. And then on the enterprise side, we're looking at things like, okay, Java EE6 is out there, and we have very wide-scale adoption of Java EE6. What do we do next? Java EE7, looking at support for HTML5 in a big way, looking at some other features around that, and then Java EE8, talking more about cloud computing and what we need to do around that. I'll come back and talk about that later on as well. Now, like I say, there's even more to this. So Java ME. A lot of people think, well, Java ME is pretty much dead. You know, micro edition, mobile phones, Java is completely irrelevant. Well, yes, I mean, to some extent, if you look at the mobile phone market at the moment, there are two very big players in that space. There's Apple with the iPhone, and then there's Google with the whole Android ecosystem. And it's fair to say that we don't have a lot of Java in either of those. Well, actually we do, but they don't call it Java. So what we don't have is a way to provide a Java platform directly there. So we're not really focusing on mobile phones. But from a Java ME perspective, it's not going away, because Java ME is micro edition. It's designed to target devices which have a small footprint. Now, that includes mobile phones, but it also goes beyond that. There's lots of other devices which are not mobile phones, which have a small footprint, which are either connected at the moment or will be connected to the internet. And so this is one big area that we're working on at the moment, is the idea of Java in embedded devices. I'll talk a bit more about that as well. Java Card. It's been around for a long time. It's one of those things that you use quite frequently, but you just don't realize it. GSM phones have a SIM card. SIM card uses Java Card. So every time you make a phone call, you're actually using Java Card. Things like that, we need to continue to develop. We need to continue to support the needs of that kind of market. And then on the side of tooling, NetBeans. Now, when Oracle acquired Sun, there was a lot of discussion, certainly in the community, in the press, about whether NetBeans would be one of the things that Oracle decided not to continue developing. They already had JDeveloper, they already had a big investment in Eclipse. Why would they then continue to develop NetBeans? But the good news is that NetBeans is continuing to be developed. Oracle see a reason for it. They see that there is a lot of people using it, and we need to continue to provide that choice in terms of development. So, quick show of hands, who uses NetBeans here? Who uses Eclipse? Okay, no, that's fine, that's fine. See, it's very interesting because that sort of distribution changes a lot depending on where you go in the world. So Europe tends to be a lot of Eclipse users, not so many NetBeans users. You go to somewhere like Brazil, and you'll find it's completely the other way around. So there'll be lots of NetBeans users, a few Eclipse users. So it does depend on whereabouts in the world you go, but yes, I understand that there are lots of Eclipse users. And that's good. I think the fact that there is a choice for an open source and free IDE is very good. So what else do we need to think about? Well, looking again at the different facets of Java, there's the technology, the innovation side, we already talked about some of that. Then there's the whole community and the participation side, what we get from Java user groups, what we get from people involved in the open source projects around Java and so on. And then there's how does Oracle fit into this in terms of joining the two together and making sure that Java continues to evolve and develop. So what we've done is really put together a sort of a scorecard of how we've been doing in terms of the different parts of Java and the different ways that you can look at it. So if we look at the technology side of things, from a list of what we've done, Java SE, one of the big things is adding support for OS X, or sorry, OS 10, I have to keep calling it OS 10, and Linux on an ARM platform. I'll talk more about that in a moment. We've had 7 update releases, more than 300 enhancements in terms of Java SE 7. Java FX, we launched version 2.2. We had version 1 of the Scene Builder, which is a tool designed to make it easier for you to create layouts and then generate an XML file automatically. We're open sourcing JavaFX, so we're going through the process of getting all of the remaining code open sourced and into the project. From a Java ME and embedded perspective, we've launched a number of new products. There's various things around that which make it easier for you to develop on embedded platforms. And then from the Java EE perspective, we've had 2 releases of Glassfish. Java EE 7 specifications are all going through the JCP, and we're getting to a point now where we have a good, clear idea of when we'll be releasing Java EE 7 as a final specification. From a community perspective, what kinds of things have we done in the last year? Well, certainly in terms of the OpenJDK project, which is the idea of, from a few years ago when we open sourced the Java development kit. A lot of people like to say that we open sourced Java, but we didn't, because, as I say, Java has lots of different aspects to it. What we actually open sourced was the Sun implementation of the Java development kit. Java, the language, is still defined through the JCP, so it's not open source in that sense. But the code for the JVM, the code for the libraries, the code for the compiler is all open sourced under the OpenJDK project. And we've started a number of new projects within there. So one of those is Project Penrose. This is looking at interoperability between Project Jigsaw for modularity and OSGI. And that's one of those things where a lot of people think, well, why don't we just use OSGI for modularity in the JDK and the JRE? And there are some technical reasons for that. We've decided that OSGI doesn't quite fit what we wanted to do, which is why we're using Project Jigsaw. We've also gone through some various updates in terms of the way that the OpenJDK project is run. So we've had some re-elections for the board that controls that and so on. And actually another project that got started fairly recently was the Sumatra project. This is a big project that we're doing with AMD, which is looking at how we can improve the efficiency of the JVM by including not just the CPU unit, graphics processing unit, and even going into things like floating point gate arrays, where you take advantage of all the processing power that you've got in your machine to help improve the efficiency of Java. JCP, as I said, we're continuing to drive that. We're trying to make things more transparent by opening up mailing lists, making sure that you can see the discussions that are going on within the expert groups as they happen. And a very nice statistic from the point of view of seeing how the JCP has really restarted is that we've actually had 21 new JSRs filed since 2011. Now, again, when Oracle took over from Sun, they made some decisions about the problems that there were in the JCP. There was no way that there was going to be a simple solution to those problems. They made a decision that was put to a vote of all the JCP members. Most of the JCP members voted in favour of it. A couple of people didn't like the idea, so people like Apache decided to leave. That's fair enough. That's their prerogative. They're quite entitled to do that. But it meant that we could actually get the JCP moving again. We could file new JSRs, we could get the whole process going so we could get Java moving again. And then Java user groups. So we've been really trying to support Java user groups and help grow Java user groups. We've done lots of visits to Java user groups, and things like where I am today is a sign of that. And we're seeing a growth in that. So there are lots of new Java user groups being created. People want to get involved, they want to share knowledge, experiences, and so on. And then from the point of view of Oracle's perspective, what are Oracle doing to make sure that Java continues to move forward? Well, Oracle are continuing to invest heavily in Java. We have the Java engineering organization, that's what I'm part of, and we're actively recruiting engineers. Almost every other day I see a new email saying some new person has joined this particular group, some new person has joined this particular group, and so on. So we're actively recruiting engineers, we're actively trying to grow the pool of talent that we have working on the Java environment. We run Java events a lot, so we have Java 1, which happened a couple of weeks ago. We're running regional events, so there's one in Brazil in December, and we'll have some more next year in other places around the world. A lot of people ask me, well, why don't we run a Java 1 in Europe? And it's a reasonable question, but really the reason for that is that there are so many conferences that happen in Europe that means that it's not actually so important for us to do that. There's lots of third-party conferences. So for example, DevOps is happening in a couple of weeks. Is anybody going to DevOps? Okay, that's good. So at least one person here going to DevOps. I'll see you there. But there's other conferences. So DevOps is a very big one. There's things like JFocus, JavaZone, Jazoom, lots and lots of conferences. And that's just the Java-focused ones. There's also things like QCon, JAX, and so on. So we don't really feel that we need to run a really big conference specifically in Europe. Community outreach, making sure that we get as much information out to developers as possible. We have an electronic magazine, the Java magazine. Anybody here subscribe to the Java magazine? Okay, now that's interesting to me. That's quite a small number. I would really strongly suggest go and have a look for the Java magazine. It's free, and it's a really nice, it comes out like once a month or once every couple of months, and it's a really good source of information. So, because it's completely free, you just subscribe to it, and you can get access to a whole lot of information. There's really good articles in there and so on. So if you take one thing away from this presentation, go and sign up to the Java magazine. I'm not trying to sell you on that in terms of, because we can sell you stuff, but simply because it is a great source of detailed technical information and so on. So, things like Java.net continue to evolve, projects on there, open source projects and so on. So we're really making, continued investment, continued progress to help develop Java, not just from the engineering point of view, but also from the community as well. So if we look at the adoption of Java SE 7, talk more about Java SE 7 and Java SE 8 and so on, we've seen a real big ramp up in terms of the downloads for Java SE 7. And so it is the case that a lot of people are beginning to adopt Java SE 7. I know that the statistics here are a bit more away from Java SE 7, but certainly a lot of the people I talk to, they are moving to Java SE 7. There's a need to do so, take advantage of new features, more performance and so on. And so that the graph on the right really just shows the switch from Java SE 6 to Java SE 7. Now, a couple of the big things that we did in the last year or so. One was the release of Java from Oracle, a binary distribution from Oracle on OS X for the Mac. Now, what happened there was that Apple decided that they didn't want to support Java specifically on the Mac OS X, OS X platform, which is fair enough. It's a heavy investment for them from an engineering perspective. And Apple have always had a bit of a love-hate relationship with Java. So they decided they didn't want to do that. And that didn't go down so well with a lot of developers. So what they decided to do was to say, well, okay, we'll join the OpenJDK project and we'll contribute all of the code that's required for things like the graphical user interface and the Mac-specific features into the OpenJDK project, which is what they've done. We've absorbed all of that into the OpenJDK project, and now, because Oracle use the OpenJDK source as the base for our binary distributions, we're now able to create a binary distribution for Mac OS X, and so you can download that from our website. It's free, and you can install it on your Mac. So that's one big thing. The other thing is Linux on the ARM platform and supporting that. So does anybody know what this device on the right here is? Raspberry Pi, very good. Who's got a Raspberry Pi? Okay, a couple of people. Raspberry Pi is a really interesting little board. If you've not heard of it, it is essentially an ARM-based processor which runs Linux and provides you with a Linux environment. So that in itself is not very exciting. But what is exciting is that you get 2 USB ports, an Ethernet port, HDMI, video out, audio out, and so on, for $25. Well, actually, no, it's $35, isn't it? £25, $35. All that for a complete Linux machine. So the real aim of this project is to get computers into the hands of school children so that we can teach real computer science to school children rather than teaching them how to use Word and how to create web pages, which is not real computer science. So we want to teach them programming, and the idea behind this is to get these devices into the hands of children. So one of the things we've been doing is working with the Raspberry Pi organization to get Java onto that platform, take advantage of the different features in the hardware and actually make Java available for that. One of the other things we're seeing is that the ARM processor, or the ARM processor design, is becoming very popular, not just for small devices. So, most mobile phones nowadays use a processor that's based on an ARM design. But now we're seeing other things. We're even seeing servers being developed using ARM processors. And that's because of the very low power consumption and therefore the very low heat dissipation, which means it's easy to keep them cool. So we are supporting Linux and ARM with a Java release, and we've actually made a binary distribution of that available as well. So that's all very useful stuff to expand the areas where Java can be used. Now, if we look at Java SE 8 or JDK 8, we're aiming for a number of new features. So, as I said, one of the big things is the idea of lambda expressions or closures in the language, making life simpler for a lot of the places where we use anonymous inner classes at the moment. But there's lots of other things that we're putting into JDK 8 as well. We're doing a lot of things around APIs, so we're finally, hopefully, going to fix all the problems with date and time and have a new API for that so that we can support all of the necessary things to really deal with different date and time implementations and so on. We're also looking at things like annotations on types. So at the moment you can annotate classes, you can annotate methods, but if you want to put an annotation anywhere else, it's not actually valid. What we're going to do is say, okay, well, let's extend that so that you can annotate, say, a parameter to a method call. And that way you could say, this parameter must never be null. And that way the compiler can make more checks to see whether you're passing a null to a method where you don't expect it to have a null. That gives us the ability to do more checking at compile time and avoiding runtime errors. So there's a lot of things around that. We're also looking at things like the client side, including JavaFX as part of the Java runtime so that you don't have to install it separately. We're looking at more HTML5 support, various things around that to really improve how the client works with Java. And obviously, security is a big issue. And what we're doing there is thinking about possibly moving away from the plugin completely for browser support. I'm not sure how many people even use Java on the browser at the moment, but we want to really try and solve that problem and move away from the idea of using a plugin. So from a JavaFX point of view, like I say, I won't spend too long on this because we'll be talking about this more later on. What we've done is to gradually improve the cross-platform support for JavaFX. Initially it was released only on Windows. We now have support for Mac OS X, and we have support for Linux as well. We've released the scene builder, which, as I say, gives you the ability to graphically create the layout that you want for your components and then generate an XML file automatically. So we continue to move forward with JavaFX. And then looking into the future, we want to continue to develop JavaFX. We want to make sure that we're supporting all of the things that people need in terms of developing rich user interface applications. Obviously, there's a lot of discussion because many people say to me, well, you know, everybody's using HTML5 now, so why would I want to develop an application using JavaFX when everybody's going down the HTML5 route? Well, it's true, yes. I mean, lots of people are using HTML5. It does give you a lot more powerful features over what we had before. But it's not appropriate for everything. You know, there are definitely places where HTML5 does not solve all your problems. And so JavaFX definitely has a place where it's very applicable. Certainly, as I say, I've talked to a lot of banks and financial institutions, and if they're doing trading applications, they're not going to write them in HTML5. They're using Java, currently using Swing, and they're very interested in moving across to JavaFX because that's the type of thing that they can do with that. So we've got various things that are coming in JavaFX 2.2 and beyond. One of the really nice ones is the move to 3D, and we showed some demonstrations at Java 1 this year of some very nice 3D environments that you can actually create using JavaFX. So it really is taking it to the next dimension. Java SE 9 and beyond, so some of the ideas that we have for beyond the current plan of release is really looking at what do we need to do with Java? What do we need to do to make Java continue to be relevant? So there's things like, how do we adapt Java to work in the cloud? So cloud computing is this lovely marketing term that seems to address the idea of running something in a data center, which may not be your data center. But there are certain things that we do need to address. The idea of multi-tenancy. Can we run multiple applications in the same JVM, sharing class library code, potentially sharing application code, but isolating the data of those applications from one another? Now, that's obviously a big security issue. We need to make sure it's done in a way that doesn't open up any flaws or security holes. So that's one thing that we're very much looking at. Project Jigsaw, now we moved that out of Java SE 8 into Java SE 9 in terms of modularizing the Java platform. It's a shame that it didn't get into Java SE 8, but the reality is that the amount of work required to do it properly is just more than we have time to do. So we did have to move it out into Java SE 9. A few other things that we're looking at, you know, is like I said, the idea of Java on GPUs as well as CPUs. But some of the sort of more out there ideas that we're discussing is, do we change Java in radical ways? So for example, how about if we just remove primitive types altogether? So let's make Java truly object-oriented. So no more primitives, no more wrapper classes, no more explicit casts. You know, you can, well, that wouldn't be none of that actually, you still would have explicit casts potentially, but the idea of removing primitive types. Now, the problem with that is it's a massive thing in terms of backwards compatibility. We would have to break backwards compatibility in a really big way. So just as a quick show of hands, who thinks that we should really break backwards compatibility to change Java? Good, that's what I like to see. No, it's interesting to me because I look at this, and I've talked to our engineers about this, and we've kind of bounced around some of these ideas, and I don't believe we're ever going to do that. And the reason I don't believe we're ever going to do that is because too many people using Java like backwards compatibility. They like taking their working code and being able to move it to a new version of Java without having to change it to make it work. And yes, you have to do some QA, you have to do some testing, but there's not a radical amount of work that's needed to be done to do that. And also one of the things that is really significant to me is if you look at languages like Scala. Anybody here use Scala? Okay. Scala is an interesting language because what the people who invented Scala have really done is to say, well, Java doesn't do the things the way that we want them to be done. So let's effectively break backwards compatibility massively and change the language so that we can do things in a more functional way, in a more type-specific way, and so on. But because I haven't seen a massive shift away from Java to Scala, yes, there are lots of people using it, but it's a good language, but there hasn't been this massive shift away from Java to Scala. I don't think people actually want to have a massive change in the way that Java works. But like I said, that's kind of my own personal opinion. So from a roadmap perspective, for Java SE, we're continuing to issue update releases for Java SE 7. I think we're currently up to Java SE 7 update 7 at the moment. Update 8 will be coming out soon. JDK 8 is scheduled, as I say, for towards the end of next year, and we're working towards a 2-year release cycle, which would put JDK 9 sometime towards the end of 2015. One of the other things we want to do is to make sure that we synchronize releases with Java SE. So Java FX will also be synchronized with Java SE. And we're going to change the numbering. So we're going to jump from Java FX 2.2 to Java FX 8, so that we have the same numbering as the Java SE. Similarly, NetBeans, we're going to synchronize that with the JDK releases. That's a slightly easier one because at the moment we're on 7.3, and so jumping to version 8 is a fairly logical jump in terms of numbering. And then we'll have NetBeans 9 when we have JDK 9. So one of the things that we do need is we need help. We need help from the community to figure out whether we're doing the right thing. So things like the JDK 8, Java SE 8 features like Lambda expressions and so on. It'd be really good if you could start playing with it. Download the early builds. They're already available through the Open JDK project. Have a look at them, see what you think. Try out the way that we've done Lambda expressions, try out Java FX, try out the different features that we're adding, and make sure that we're doing it in the right way, because we've still got time for feedback. If you really object strongly to something, you can still provide feedback. There's a bug reporting system that's available, and so if you find things that you think need to be changed, you still have the opportunity to do that. But the more input we can get from real users, the better, because it's going to help us develop the product that you actually want. So talk a little bit more about the embedded side of things. This is something that we are seeing is becoming a bigger and bigger thing in terms of the IT industry. More and more types of devices are becoming connected to the network. The cost of entry in terms of providing the processing power and the networking to get devices connected to a network has become much, much lower. Like I say, the Raspberry Pi is a full-featured, network-connected, programmable device, $35. But that's like a massive device compared to embedded devices. So we're really talking about the order of a few dollars will get you enough processing power, enough memory, and network connectivity to do useful things. And so what we're looking at here is a number of different sort of areas in markets. So there's things like smart metering. This is a very big thing that the European Commission are driving at the moment, is how to help people understand how much power they're using. So if we can put some intelligence into the electricity meter, then we can also get more information out of that. We can see how we're using electricity, how we can help to reduce electricity usage, and so on. There's things like cars are becoming much more connected, the ability to process information, gather telemetry, and so on. The idea of healthcare and being able to monitor people remotely so they don't have to spend time in hospital. You can have the same monitoring at home, you can reduce costs that way, but you need to have the intelligence. So there's a whole range of areas that we're looking at in terms of how embedded processing can be used, and therefore how we can actually apply Java to that. Because Java clearly has a lot of advantages in terms of its ease of development, the fact that lots of people know how to program in Java. You don't have to deal with the problems you get in C and C++, with explicit pointers, memory references, and so on. And from a sort of product offering and the way that we actually provide support for this, we try to cover the whole range of things. So at the very bottom, as I said, we've got Java Card. This is really aimed at devices that have literally a few kilobytes of memory, so very, very small footprint. Then, as I said, Java ME is not going away, but it is being more focused on embedded devices. Small footprint devices, less than 500K, aimed at things like the ARM Cortex processors, which are low power, low processing power as well as actual physical power. And then you've got things like the Oracle Java embedded, I can't remember what this one is, client, that's it, Oracle Java embedded client, which is really a thing that you can put onto slightly bigger devices that maybe have a megabyte of memory and so on. And then we go all the way up to things which can support a full Java SE environment. So we have Java SE embedded. And if you think about the very early days of Java, when Java first came out, typical desktop PCs may have had a whole 8 megabytes of main memory. So Java will run in small devices, even Java SE. So you don't need to have, gigabytes of main memory to run Java. And so if we look at that in terms of how we see that being used, we've got the idea of small devices being able to gather information, gather data, potentially do some processing and analysis of that data to filter it, passing that through some sort of gateway which can concentrate the data from a large number of sensors, again, analyze it, do some filtering, and then pass it back to the data center where you can do some big data mining kind of application. And so our marketing people have come up with 2 phrases for this. We now have embedded to enterprise or device to data center. So nice catchy phrases for that. But it is the idea of being able to use Java all the way across the design of this architecture. How Java Card fits into that is really about security, because Java Card gives you the ability to have a very secure client application so that you can guarantee that the person providing the information is who they say they are. And that gives us the ability to really sort of tie this all together, because lots of devices connected to a network means potentially lots of devices that you can attack from a security perspective. We need to make sure that doesn't happen. So again, from a roadmap perspective, really Java Embedded is tied into the same release schedule that we're looking at for Java SE. So there'll be new versions of Java Embedded, there'll be new versions of Java ME. And one of the things we're really doing there is moving Java ME into a more modern version of the Java language. Currently, if you use embedded Java, you're actually stuck in 1.4.2, which I find really hard to believe. But so you can't use things like generics, for example. So now we'll be moving that forward. We'll have full support for Java SE 7 and then Java SE 8 when it comes out. So you'll actually be able to use the same programming language in terms of developing your applications across all of your different parts of the application. So we look at Java EE, so switch from the very small up to the very big. Java EE has gone through a lot of changes over the years, and this is really the history of Java EE. Started way back in 1998 when we had the Java platform for the enterprise, and then we came up with, we called it Java 2 Enterprise Edition, version 1.2, and then we went through various iterations of that. But what we've seen is really a continuation of trying to simplify life for enterprise developers. The whole point of Java EE when it first came out was to say, how can you have developers who can create components, things like EJBs, things like servlets, where they don't have to concern themselves with all of the details underneath. So what database am I using, what transaction manager am I using, what security manager am I using? That's left to the container to handle all of those details. And so we came up with this idea of enterprise Java beans, servlets, containers, and all those good things. But who uses Java EE here? Okay, reasonable number of people, right. So you will know of the issues that kind of have been there for Java EE. So for example, entity beans. Anybody here actually use entity beans? Okay, yes, you see, that's fine. There's a few people who do, but not many. Very few people use entity beans. They just didn't prove to be very popular. And so one of the big things in terms of Java EE5 was by adopting some of the features of the Java SE5 language, most notably annotations, we were able to have a big impact on how easy it was to do things in Java EE. So by using annotations, we could do dependency injection, inversion of control. We could adopt a lot of the open source framework ideas that people had created in order to solve the problems that made life hard for Java EE. So things like Hibernate for persistence, things like the Spring framework, things like struts for the presentation layer. What we did was pull all of these ideas into Java EE so that we could standardize it and make it much simpler for people to use these things. And that really solved a lot of the issues that we had in terms of making life much easier. You know, the whole Java persistence architecture, solving all of those problems, making life a lot easier. Java EE6, we made some smaller changes. One of them was to start doing things like profiling and having profiles associated with the platform. Because what we'd ended up with was the situation where we'd added more and more bits to it, and to have backwards compatibility, we ran into the problem of, it just got bigger and bigger and bigger. So we needed to have a way of trimming things down again. And so in Java EE7, we're going to see a continuation of that. So from a focus and direction point of view of Java EE, what we're looking at here is continuing standardization. So taking ideas from open source frameworks, taking ideas from open source projects, and bringing them into the standard. So you don't have to think, oh, am I using Hibernate with struts or Hibernate with Tapestry and Spring, and making it just easier because all of the standard parts are there available for you. Productivity, simplifying the process, further use of annotations, further use of plain old Java objects rather than specific types of classes for things, that kind of idea. Making sure as far as possible we get portability across different application platform vendors. So we don't have to worry about if we're moving from WebSphere to WebLogic to Glassfish. Now I know that's a wonderful idea, but it's never going to happen in reality. But as far as we can from the standardization point of view, we want to make that as simple as possible. Extensibility, because yes, people do want to add more features. So WebLogic, WebSphere, Geronimo, whoever, want to be able to add features that are outside of the specification. And we need to have a way of doing that as simply as possible. And as I said, modularity, so that we can say, if you're writing a web-based application that you don't need all this extra things at the back, then make it simpler for you to create those applications simply by using the necessary modules from the system. Java EE community is a big one. So if you look at things like the Java EE specification, there's actually 14 JSRs associated with that. There are 19 spec leads. There are 32 companies involved in the development of Java EE7 and 201 experts. So it's a very big set of people involved in the definition of that. Again, looking at java.net, there are 23 active projects on java.net for Java EE7, and Glassfish is it's the reference implementation for the specification. So it's open source, free, and it guarantees that you know that the specification can be implemented. And so it's a very useful thing to look at in terms of deploying your applications and testing your applications before you potentially need more commercial features. Java EE6 has been very widely adopted, so it's not just Glassfish. Like I said, it's IBM with WebSphere, JBoss, Oracle. There's a few other projects that have been created where people have produced implementations based on the standard. Now, for Java EE7, what we're looking at is a focus on HTML5, because that's something that people really want. They want to be able to generate clients that are using HTML5. So we need to make sure that from the point of view of things like JSON, we have the ability to deliver that kind of content. We need things like caching and so on. So these are the main areas of focus for Java EE7 that we're going through at the moment. Now, one of the big things was that initially Java EE7 was going to be focused on the cloud. So we wanted to bring Java EE into the multi-tenancy, resource management kind of world where you had elastic computing and all these good things. But what we decided fairly recently was that we weren't going to do that. We didn't exactly drop cloud computing from Java EE7, but the decision was made that because cloud computing is still in its early years, there's no kind of concrete agreement on all of the standards that are required for this. So rather than trying to implement standards that don't exist in Java EE, we would wait until people had figured out how to standardize some of the features before we try to include them in Java EE. On the other side of that, what you find is that a lot of the things that people want from cloud computing already exist in Java EE. So if you think of the way that containers work, you actually have some of the features that are available for cloud computing. So you can have a container which can be dynamic. There's no problem from the point of view of the component, the EJB or the servlet. That container can be dynamic. How it's implemented underneath means that you can change how many processors are allocated to it, how much memory, and so on. So a lot of the fundamental concepts are there. What we really need to do is add things that will enable us to provide the kind of management, resource allocation, those types of things to Java EE. One of the other things that has become very big is the idea of NoSQL. And so we need to make sure that we're supporting that. So there's the idea of persistence for NoSQL databases. So things like MongoDB, Oracle NoSQL, Cassandra is planned. So there's definitely work going on in terms of addressing not just the traditional needs of your relational database management, object relational management, and so on, but using things like NoSQL. Again, looking at Java EE8 and beyond, like I say, the idea there is to look at things like cloud computing and multi-tenancy, software as a service type applications. How can we provide the necessary fundamental parts there? Incremental delivery of JSRs, so we can update JSRs where necessary to support new features. Concurrency is another big thing that we're looking at, because of course, if you look at the specification for Java EE, you're not allowed to create new threads within your EJBs. So we need some way of allowing you to have concurrency, so you can break up workloads into multiple threads, but without necessarily doing it through a direct thread object. So that's one of the big areas that we're working on there. And also, when Jigsaw comes in, we'll build on top of that to give us more support for modularity. So just to conclude then, basically, Java is continuing to move forward. We are continuing to provide the features that we hope that developers need. We're continuing to adapt to the new platforms that developers are using. And that's very important to make sure that Java continues to become a relevant language and continues to be used by all you as developers. The Java community is very important to us. And so Oracle are really trying to make sure that we are in touch with the community, that we address the needs of the community, and we keep people updated and so on. And I like to say that Java is not the new COBOL. So we're not aiming to just say, okay, Java's done, let's stick it on a shelf, let people use it. It's, we're going to continue to develop it, we're going to continue to make it available in whatever form people need it to be. So that is about it. I don't know, I've got like maybe 1 minute for questions if there are any. Oh, I see a question there. Might have to shout. Oh, microphone.
Well, if you don't mind, I actually have two questions.
Go right ahead.
First, you were talking about Java 7. It's a very good idea, and I tried to move to Java 7, but I encountered really big problems with rational passes. I mean, if I have some, let's say I have Russian Windows, right? And I try to run some Java applications, it just won't do if I have some Russian letters in the past. And it's a problem for, I believe, not for only for me, but for the whole internalization thing.
Right, okay, I'm very surprised at that. I will give you my card, and, well, because I can't answer that question directly, because I honestly don't know the answer to it, but I am interested to hear that, because I know that we upgraded like Unicode to the latest version of the Unicode code set. So I would like to know more about that specific problem, and I will take it back to our engineers, because that's the kind of thing we need to know about. So I'll give you my business card on that.
Thank you. And my second question, if you don't mind, it's a more strategical way. Well, you were talking about JavaFX. It's a kind of competitor to Microsoft Silverlight
Yes.
to some extent.
Yeah,
And,
Flash,
but I believe both JavaFX and Silverlight loses greatly to Flash. For now, Flash is ruling on this market. So my question is, how are you going to deal with it? Of course, Java is more powerful than Flash, but...
Yes, I mean, it's always one of those things where people say, well, you know, Flash is great because it does lots of things, and so lots of people use Flash. Well, there's two things that I think I would say about that. One is Adobe are not really putting as much effort into Flash as they used to, because they're now seeing HTML5 as more the way that people are going in. And so the way that I really pitch JavaFX, which I'll talk about more later on, is it's more about taking advantage of the things that you already have. So you're Java developers, so you know how to program in Java. Now, okay, let me quick show of hands. Who knows how to program Flash? Okay, now that's fine, because obviously this is an audience for Java users. So there's not many people here know how to program in Flash. So if I say to you, I want you to develop a graphical application, and you've got a choice between Flash and JavaFX, which uses Java, in this audience here, most people would go for JavaFX, simply because they know how to program in Java. So it's not necessarily about saying that JavaFX is substantially better than Flash. It's about providing an alternative so that people who know how to program in Java can continue to use their skills. And also, because it's Java, any of the libraries that you use for other things can also be used directly into that application. So if you've got a library that, I don't know, handles some piece of hardware or something like that, then bringing that into a JavaFX application becomes very simple, versus if you try and integrate that with Flash, if you've only got a Java API and you've got to build a Flash front end, it's more complicated. So I'm not trying to say that JavaFX is a replacement for Flash, Silverlight, or HTML5. It's a complementary technology.
I say thank you.
Okay. Right over there. Yep. Oh, we've got a microphone over there. Okay. Oh.
Okay. Well, small question about relationship between Oracle and Google. As I know, as everybody knows, was some lawyer problems, and will it some bit warming up?
I'll repeat the question. Don't worry, sir. Keep going.
Will it warming up relationship between Google, because it's actually one of the biggest companies which use Java, and it's will be pity if it's defeated with Java.
Okay, so the question was, what's our relationship with Google? Because obviously there has been a lawsuit between Oracle and Google over Android and their use of Java APIs and so on. Well, unfortunately, unfortunately for us, the decision was made by the court that they hadn't infringed on certain patents, that there was an issue over whether you could copyright an API, and that was decided, that went against us. So essentially we lost. There was no big sort of decision which made a difference to us. Unfortunately, the relationship between us and Google is not a good one at the moment. We just recently said that we were going to appeal the lawsuit. Now, this is not my decision. This is a decision that's taken way above my pay grade. And so, unfortunately, I don't see our relationship with Google becoming warm and fuzzy anytime in the next few months, simply because we've decided to appeal the court case. It really is a shame from my perspective, because I'm a technologist. I don't care about the politics of this stuff. I'm a technologist. I'd really like to be able to use Java. And so, Android essentially from a programming perspective is pretty much Java. There's a few APIs left out, but it's really Java. So it would be nice if we could work more closely with Google and have a much more friendly relationship with them, because they do use so much Java. But like I say, unfortunately at the moment that's just not a reality because of politics. Yeah.
What Oracle thinks about Scala?
Okay, good question. What does Oracle think about Scala? Well, Oracle thinks Scala's really good. No.
Does they have
Sorry?
special plans for Scala or something else?
Right, okay. We have no special plans for Scala because it is not a language which we develop. But, see, what we have done is if you look at Java SE7, we introduced the new bytecode, invoke dynamic. Now, the primary reason for introducing that new bytecode was to improve the performance of languages that were compiled into Java bytecodes that use dynamic typing. So, other languages we see as a good thing. What we like to do is encourage people to use the JVM. Even if they don't use Java to generate the bytecodes that run on that JVM, we want people to use the JVM. And a lot of people have said that the JVM is more of the crown jewels than Java is. So we're very keen to have other programming languages run on top of JVM. And so from a Scala perspective, it's just one of many languages that can be compiled into bytecodes. And we are looking in JDK8 and even JDK9 and beyond at what we can do to make it better for other languages to run on top of the JVM. So we definitely focused on things other than pure Java. Okay.
So last question.
Okay.
Is there Oracle initiative for support Java education in university?
Aha, good question. Right, so the question is there an Oracle initiative for supporting education for Java in universities? To which the answer is most definitely yes. The reason I say that is because I was actually involved in a project within Oracle a few months ago. One of the things we've done is, we may not have publicised it too well, may not have publicised it quite well enough, is there's two parts to Oracle that are involved in this side of things. There's one called Oracle Academy, and then there's one called Oracle University. So Oracle University is a little bit of a misnomer in the sense that it's not about universities. It's really Oracle, the training side. So we charge people to come and take our courses. It's a nice way for us to earn money. And we have Java courses, which are aimed at professional developers. Oracle Academy is the more philanthropical side of things, which works with universities. So we have a relationship with lots of universities throughout the world, and we provide various things to them in terms of Oracle licenses and stuff like that. But what we've done is we've actually allowed universities to use all of the Oracle training courses, the professional training courses, can now be used by universities and adapted to the curriculum that they're creating for undergraduate students. So you can, if you go to the Oracle Academy website, Google it. If you go to the Oracle Academy website, there will be a link from there which will tell you about the ability to download the courseware from Oracle University and how you can use it in undergraduate training courses. Because one of the things I did was I actually did a mapping between the various sections of the Oracle University courses and how they map to the ACM computer science curriculum, so that it gave people an idea of which bits of the courses they could use to teach which bits of the curriculum. So yes, we definitely are. And if you're interested more in that, come and talk to me, because we can talk more.